21, 22. I don't know. We're working on the lab time project. So, just in case you're at this point in the video and you don't know, like, I haven't really said what I'm working on, and basically it's a current point mass steady state lap time simulator program that I'm tweaking, and I want to turn it from a point mass vehicle model to a bicycle model. And so the whole project is made like with Python, and then yeah, I've just been tweaking the code and um reading like some other project papers about how like they approach this problem, and they have some of the math they showed, so using that I'm putting together sort of my own version of it. And last time I was implementing the IPOPT function routine in this file, but considering that this is a pretty hefty, not hefty, but loaded file to begin with, I decided I want to isolate this whole routine in a separate file. So now the problem is I need to find a good set of input variables to create at least one output. So I'm going back to the original code, the original acceleration envelope calculator file, and trying to understand what numbers are outputted by these lines here. Now so that's what I've been trying to do, and I've been running it here, but this is the issue I've been running into. Function object is not subscriptable. So let's search that up. Function object is not. Okay. So it's saying I have a list and a function that have the same. Oh, I see fz arrow. So it should be fz arrow underscore fx grip fx arrow fx drive. This should work, no? Do I have to restart it? I feel like I have to often restart this kernel and then run it, and then it takes a minute. Oh, see? So yeah, this is like some of the other output um from this lap time simulator project. Um I'll put a link in the description to the link to the original open source project. Um, it's really very grateful for this guy who made it because, you can look under the hood and see how it really works. So there's 10 iterations. And let's see what sort of. So these are the acceleration. These are the longitudinal force at the wheels, I believe, and then drag, tractive force, down force. But why is the acceleration so low? Or is that considered high? No, I think this is normal. Okay, so we want some values. Okay. Um, okay, so we're gonna make a separate file now. Um, so file, new window. Let's do the sandbox. Okay, let's stick to five, for example. So if fx c0 is equal to fx drive, then fx drive is equal to 7338. Okay, we'll have to calculate the weight transfer too. Cog X would be 1.78.